a warm tank and a cold tank and that temperature gradient between.
Yeah.
So that's what you were saying. You can sort of get them close to the same temperature and they're compatible.
Exactly. They're close to the same temperature at this point.
All right. You also talked about the availability, propane, supply, transport. It's all figured out. It's nothing new. So that's a pretty widely available fuel, I guess?
Exactly. It's not an exotic fuel.
Right.
It's used in several industries. As you said, your barbecue burner at home as well.
Well, I don't
Maybe
have
not
space
the same
propane,
grade, but you know, it's something that is already established not in Europe, but you know, globally.
Globally. All right. How much? I mean, this is another thing to sort of talk about. Are we talking about, it's so hard to get a scale of how much fuel there is in the vehicle.
Yeah. Mentioned earlier, it's roughly 55 tons total weight of
Between
the vehicle.
both.
In total, including the structures. And out of that, approximately 35 tons is liquid oxygen and 14.5 is liquid propane. So you can imagine it's a large amount of propellant, and that's still a small to medium size vehicle, but it's still a lot of propellant that we need to fill onto.
That's the thing that a lot of people don't understand. Like a jet plane, right? A jet plane uses jet fuel, but it just carries the jet fuel. And it gets its oxygen for the combustion from the air that it's flying through, because by definition, air, it's right there in the name, airplane. Right? Rockets don't get to do that. In order for a rocket to operate in the vacuum of space, they need to carry their own oxygen to create that combustion when there's no free oxygen to sort of gather from the air. They're not in the air anymore, right?
Exactly. That's why we don't only carry the fuel, but also the oxidizer, liquid oxygen in that case.
Yeah, and there's more than double the amount of oxygen that you have to carry as fuel.
Indeed. It depends on the actual propellant combination and your optimal mixture ratio, but in our case, it's more than double the actual
combustion. All right.
The actual mass.
Well, the rocket seems to be coming alive here.
Yeah, I got distracted for a second seeing the
screen.
bleed. That's really, really good to see that we're reaching this point.
Excellent. The clock continues to tick down here, folks. We're now less than 24 minutes away from launch. What are the vents right now?
So it's actually the bleeds of the engine. So we're in the process of conditioning the engine thermally at this point.
Conditioning the engine thermally. All right. And that's a normal sort of thing. That's not a leak. That's a controlled, intentional.
Intentional. This is expected. It means that so far we're still green for launch.
All right. I believe here we've got another bit of video to play for y'all. I'm going to keep joining us. Thank you. 23 minutes away. Let's roll a video about some production here.
When we set out to start Isar, the world, frankly, looked quite different compared to today. Space is now a critical geopolitical topic.
Have more and more needs to get space access. The number of customers is increasing worldwide.
The market has been shifting quite a lot actually for the last year or so. All very good news for launch service providers as demand is increasing in so many different ways.
You can have 1,000 satellites sitting on a shop floor, but if you don't actually get them into the right orbit at the right time, it's all a bit useless. At this point, the challenge in the space industry is not on a technological level, but a real challenge is how do you build tens and hundreds of rockets? You have to really design for industrial scalability from day one. And that's what we did at Isar.
What is unique about Spectrum is the fact that we have thought about industrialization and scaling very early on. We have a great manufacturing capability. We have a great space launch ecosystem with test rigs and all the capabilities that belong to it.
And so we ended up actually insourcing almost everything, or at this point we own about 90% of the value creation of the entire launch system, which not only allows us to actually scale our production, but it also gives us a lot of independence.
The first step is enabling to access the space, and then you are getting lots of new opportunities.
Now, if we want to develop a new system or upgrade the current system that we have the capability and the capacity to do so.
И всем здравствуйте, с вами Space, и вы попали на прямую трансляцию запуска ракеты Isar Spectrum с миссией Onward and Upward. Запуск запланирован на сегодня 25 марта в 20:06 по ETC. Через 20 минут стартовое окно до 22:50 по ETC с орбитальной стартовой площадки на ракетном полигоне Андёя в Нурланде в Норвегии. Onward and Upward. Второй испытательный полет ракеты-носителя Isar Spectrum в рамках программы Европейского космического агентства Запуск. Этот запуск доставил на Солнечно-Синхронную орбиту 5 кубсатов и один неразделяемый эксперимент кубсат. А именно порезозагрузка. Первое. Кубсат. Технический университет Берлина. Далее. TriSat-S. Университет Марибора. Платформ 6. Endurosat. Также FremSat-1. Также Space Team Sat-1, космическая группа технологического университета Вены, и также Let It Go, Good Bad. Это неразделяемый эксперимент, то есть неотделяемая нагрузка. Второй полет нашей ракеты-носителя Spectrum знаменует собой важную веху, являясь одновременно квалификационной миссией ракеты и ее первым полетом с порезанной нагрузкой. Onward and Upward символизирует наше неустанное стремление к прогрессу и постоянному совершенствованию, отражая нашу решимость развивать успехи и уроки, извлеченные из нашего первого испытательного полета. Это будет второй запуск ракеты Spectrum и первый в этом году. Первый запуск ракеты-носителя Spectrum, состоявшийся 30 марта 2025 года, в котором ракета через 25 секунд после старта потеряла управление, еще через 5 секунд отключились двигатели, и ракета упала в воду недалеко от стартовой площадки. Ракета-носитель Spectrum — это двухступенчатый ракет-носитель для орбитального запуска, разработанного немецким стартапом компании Isar Aerospace. Высота составит 28 метров, диаметр 2 метра, грузоподъемность на несколько земную орбиту 1 тонна, на Солнечно-Синхронную орбиту 700 килограмм. Всего, как уже говорилось, был произведен один неудачный запуск. На первый ступень становится двигатель Aquila, который работает на пропане и жидком кислороде, а на второй ступени один также двигатель Aquila, также работающий, понятное дело, на пропане и жидком кислороде. Тяга одного двигателя составляет на уровне моря 75 кН, собственно, общая тяга 9 двигателей первой ступени 675 кН. Разработка ракеты-носителя Spectrum началась в 2010-х годах. Большая часть ее конструкции была разработана собственными силами. Ключевой целью в процессе разработки была цена в $11 700 за килограмм порезагрузки, а также максимальная гибкость для удовлетворения самых разнообразных требований порезагрузки. Компания Isar Spectrum договорилась о проведении запуска Spectrum как космодромов Андёя в Норвегии, так и с космодромом во французской Гвиане. Среди первых заказчиков ракеты-носителя Airbus Defence and Space, немецкий космический центр DLR и Spacefind Inc. Компания Isar Spectrum рекламирует ракеты-носители за ее значительную гибкость, позволяющую лучше удовлетворять различные потребности потенциальных клиентов. По данным компании, подавляющее большинство компонентов Spectrum разработано и произведено собственными силами, включая двигатель Aquila. Это относительно компактная ракета, отчасти благодаря высокой плотности энергии ее топлива, которое предоставляет собой комбинацию жидкого кислорода и пропана. Двигатель второй ступени также оборудован системой многократного зажигания. Топливо подается в двигатели под высоким давлением через турбонасосы. Расследование по первому неудачному запуску показало, что вентиляционный клапан ракеты-носителя неожиданно открылся, что привело к потере управления ориентацией в начале маневра крена. Компания Isar Spectrum — это немецкая космическая компания, базирующаяся в Оттобуне, недалеко от Мюнхена. Компания была создана в 2018 году. Компания названа в честь реки, протекающей через Мюнхен. Основателями являются Даниэль Метцлер, Маркус Брандель, Йозеф Петер Флейшманш. Количество сотрудников порядка 450 человек. Кстати, также по поводу первого неудачного запуска, компания называла первую миссию успехом, потому что они так не рассчитывали в первом запуске добираться до орбиты, а главной задачей было оторваться от стартовой площадки. С этой точки зрения, основная задача в миссии была выполнена, они взорвались на старте, и на этом спасибо. Система прекращения полета, кстати, заработала в пассивном режиме, так как ракета находилась в нужной зоне для этого. О, еще один перенос. Замечательно. Что-то я чувствую, то, что мы сегодня не улетим. Кстати, изначально этот запуск был запланирован что-то еще на январь, по-моему. Потом его еще кучу раз переносили. Потом чисто там на день, на два кучу переносов было. Вот, наметились, дошли до сегодня. И опять очередной перенос. Так, через 25 минут это выходит, запуск будет в 20:30 по UTC, наверное, да. Стартовое окно у нас, кстати, до 20:50, то есть еще на 20 минут осталось этих переносов. Блин, что тут рассказывать про эту ракету? Ничего особо интересного. То есть, ну вот, первая ступень, 9 двигателей. Собственно, вторая ступень, 1 двигатель, межступенчатый отсек вот этот, где находится двигатель второй ступени, и обычный двухстворчатый обтекатель пореза догрузки. Вот, кстати, сравнение размеров ракеты Spectrum, вот она, да, с другими ракетами-носителей. Ну, типа, вот от Long March Size до Астры, а вот это даже не знаю, что самая маленькая. Расположение двигателей. Ну и просто фоточки того, ну это еще из первого полета все. Вот прожиг. Ну и, собственно, видео крушения.
Yeah, engine ignition. And we have liftoff of
Это из
Spectrum.
первого запуска.
The vehicle has cleared the tower and is now starting the pitch over maneuver.
Ну вот, через 25 секунд просто была потеряна ориентация. Вот, потом движки выключились. Ну и все.
All right, folks, as promised, we've got that information. Currently, right now, we do not have clearance for launch from the range. It sounds like there is a boat on the range right now. Something we've seen before, something we've heard about before.
Также вот видео подготовки к этому уже запуску. А это вот прожиг второй ступени. И тем временем у нас остается еще аж 20 минут до запуска. А, на 20-21 перенесли, получается. А, вот. 18 минут. На 20-21 перенести получается. По UTC. Ну что, ждем.
Enabled also two part.
So we put together some engines. We need something that Folks, another update for you. You've noticed that the clock has continued to tick down. We are waiting for the range to clear. A little bit earlier, we mentioned that the range was currently in violation. There was a boat on the range that was preventing the rocket from launching. Nico, that's got to be frustrating. The rocket's looking ready.
It is. The vehicle seems to be ready, loaded, ready to go. But this is now out of control. Let's hope that it gets resolved as quickly as possible.
And absolutely important for public safety as well.
Yes, it's definitely a precaution that is necessary. But still, it's something right now that we wish wasn't there.
Yep. So, since the clock is continuing to tick, let's continue to talk about the mission here, shall we?
Yeah, we can do that.
All right. So far today, we've been preparing this rocket for launch. And so far this week, there's been a lot of work going. Let's talk about some of the milestones, the fueling, all the things that had to happen to get us here where the rocket was ready to go.
We can start maybe even before that, like a day before that, which is when the vehicle is being rolled out to the pad and then erected with a transporter erector. All the umbilical connections are being done. All the health checks are being done on particular systems like the fluid system, on valves, on structures, on avionics, on propulsion. And then comes the launch day, which started today. It was an early day. Maybe around 11 a.m., 11:30 is when we started rigging the pad, making sure that everything is prepared. And then there are some milestones along the way. Obviously, powering on the electronics, making sure that the onboard computers are reading as they should be. They have all the health checks passed. Then again, doing similar checks for fluid system, pressuring the tanks in terms of cycling them initially. And then there is a decision point before going into actual loading of the propellants. So this seemed to work very well. Within our time plan, we were even faster than what we initially thought. I have to say here, operations are running very smoothly. And with that, with the propellant loading, we then pass some further checks in order to go into engine conditioning as well. We can still see it actually, at least on our screens, we saw it earlier, the bleed through the engines. This is the actual chill down that's happening.
There you
go.
Yeah.
This is the conditioning. We need to make sure that the temperature in the engine is as we would expect for them to ignite properly and have their nominal behavior. So this is the purpose of this bleed coming off the side.
So you don't want to surprise them with a big temperature change. You don't want them to be a sort of ambient outside temperature and then all of a sudden hit them with cold propellants. You sort of precondition their temperature.
Exactly. Yeah, precondition them and also make sure that the fluids themselves, when they get to the turbopumps, when they get to the thrust chamber, have the nominal or are within the nominal range of temperatures that we accept, to also ensure that the performance of the engine is going to be as we test it on the test rig and as we test it in stage testing.
Makes sense. So I'm going to manifest. Stand by. I just got the call that we are preparing for auto sequence start. We just crossed under T-minus 10 minutes. Let's manifest some positivity here. So I'd love to see
great news.
This launch. But again, if the range does clear, as the rocket continues to count down, let's talk about what we would see after engine ignition and liftoff. I'm going to think positive.
Yeah, or maybe also auto sequence, because that might be a term that people don't know. This is the point in time. It's roughly 2 minutes out from the actual liftoff, where the vehicle gets full control authority of itself from the pad. Meaning we enter a point where we do some final checks, some final alignment of our GNC, so guidance, navigation, control. We start going into pressurizing our tanks to their flight pressures. We're going into the final phases of the engine chill down. So again, this conditioning that we mentioned earlier. And then a couple of seconds before the actual liftoff, we have ignition of all 9 engines. And as soon as all the checks are passed, we open the hold and release mechanism. So this is the structural part of the pad that holds down the rocket while it's hot firing. And after that, nothing else holds it back. So we have liftoff.
Gotcha. So it actually starts the engines up before it's released for flight to make sure the engines sort of settle in, I guess you could say.
Exactly. And you can also open it without having thrust. You need this push from the bottom to propel you at this point. And that's where we have a liftoff. In the first phases, right after liftoff, we have a vertical rise. We can see also this animation right now, which is then transferred into a pitch over, or rather getting from vertical to horizontal, because that's what we need at the end to get into orbit.
You'll notice at the bottom of the image there was no boat on the range.
Yes.
Which is why we're able to go into the animation.
Max Q is shown here. This is the point of maximum aerodynamic pressure. So this is the point where we have the highest load on our structures. We're still low in the atmosphere, so some density is there, and at a high speed, so we get this high load. And at some point, roughly 2.5 minutes in, we're going to reach main engine cutoff. So we're shutting down the engines in stage 1 and stage separation. This is the point where the second stage detaches from the first stage and then continues to, or first ignites and then continues to burn in vacuum crossing the Kármán line, 100 kilometers. That's the
100
definition of space, essentially. And after some points, since we've exited the thick part of the atmosphere, we have fairing separation. So the payloads are then exposed because there is no atmosphere anymore to harm them. And while this engine is burning, this is going to be roughly 5 minutes of stage 2 burn time before the so-called SECO, that second engine cutoff. This is when we actually become orbital, but we're not in the final orbit yet. We're in the transfer orbit. We need to wait for roughly half an orbit. It's approximately an hour. You can think of it, we're going once or half around the Earth.
Halfway around the planet.
Halfway around the planet, exactly. And that's when we do the circularization burn. It's a very short pulse of the engine in the order of some seconds. And with that, we are placed in the final orbit, the targeted orbit. And some seconds later, we release the spacecraft into this dedicated orbit. And half an orbit later, so we still coast a bit further with our upper stage, we perform a deorbiting burn. This is where we flip essentially the stage over, do another short burst. And with that, we reduce the velocity and allow it to safely go and enter into the atmosphere.
Back into the atmosphere. Right, being a good space citizen to make sure you don't leave orbital junk up there just floating around.
That's the whole purpose of that. Not leaving any debris in orbit.
Again, if you're just joining us, I know more and more people come and join the stream the closer we get to liftoff. The latest information we had was that we did not have clearance from the range to launch. There was a boat on the range. And this is very important. It's very important that when we launch these rockets, we want to see the flight, we want to get the data, but we also want to make sure that we follow all safety protocols. We keep the public safe. We keep the people that are working out there on the boat safe. So the latest information was that there was a boat on the range that was going to not allow us to fly. However, the clock is continuing to count down right now. So we are going to continue telling y'all about the mission as we've just crossed under T-minus 5.5 minutes. And as soon as we have any more information, I believe the hope is that that boat is able to clear out of the range right here as we get down. We'll be safe. We follow the safety protocols, but there still is a chance that we get the rocket off the pad tonight.
Yes, let's hope so.
Let's hope so. Manifesting the positivity here. Okay, we are now less than 5 minutes away from launch.
И еще раз всем привет, я напоминаю, что мы смотрим прямую трансляцию запуска ракеты Spectrum с Isar Spectrum с миссией Onward and Upward. Второй запуск ракеты Spectrum. До запуска у нас остается менее 5 минут. Запуск запланирован на сегодня, 25 марта в 20:21 по UTC с орбитальной стартовой площадки на ракетном полигоне Андёя в Нурланде в Норвегии. Второй испытательный полет ракеты-носителя Isar Spectrum в рамках программы Европейского космического агентства и Запуск. Это запуск до Солнечно-Синхронную орбиту, 5 кубсатов и один неразделяемый эксперимент. Второй полет нашей ракеты-носителя Spectrum знаменует собой важную веху, являясь одновременно квалификационной миссией ракеты и ее первым полетом с полезной нагрузкой. Onward and Upward символизирует наше неустанное стремление к прогрессу и постоянному совершенствованию, отражая нашу решимость развивать успехи и уроки, исключенные из нашего первого испытательного полета. Это будет второй запуск ракеты-носителя Spectrum и первый в этом году. Первый же запуск ракеты-носителя Spectrum состоявшийся 30 марта 2025 года, в котором ракета через 25 секунд после старта потеряла управление, еще через 5 секунд отключились двигатели, и ракета упала в воду недалеко от стартовой площадки. Да, то есть от первого запуска пошел уже почти год, ну посмотрим. Не знаю, мне что-то кажется, что этот запуск будет неудачным, ну вот почему-то мне так кажется. Ну, 3,5 минуты у нас остается, пока можем поговорить про следующие ближайшие запуски, которые у нас будут в ближайшее время. А именно, 29 марта в 7:53 по UTC запланирован запуск ракеты Atlas-5 в версии 551 с миссией Amazon Relay 05. Первый запуск ракеты Союз-5, новой ракеты Союз-5 с стартовой площадки 45 первых на космодроме Байконур в Казахстане перенесли на 2 дня с 27 на 29 марта. И на час вперед теперь запланировано 15:00 по московскому времени, 29... Ой, так и на 14:00, короче, по московскому времени, 29 марта. Запланирован первый запуск ракеты Союз-5. Далее, 30 марта запланирован транспортер 16 на Falcon 9. До конца месяца также запланированы запуски ракеты Электрон с миссией Doctor of the Stars. С QQ-2 с известной полезной нагрузкой, Кинетика 2 с космическим кораблем Кюнс Хоу, первый запуск ракеты Кинетика 2. компании K-Space. Также первый запуск ракеты Лонгмарш-12Б, многоразовой ракеты Лонгмарш-12Б, и первый запуск ракеты Тянь-Лунг-3 с неизвестной полезной нагрузкой. Также до конца месяца вообще запланирован до сих пор в расписании запусков третий запуск ракеты Ньюфгрен с миссией Брюбер Блок 2 FM2, где будет использоваться первая ступень, которую уже совершил полет в прошлом втором запуске, но что-то по нему вообще никаких ни обновлений, никакой ни информации нету, поэтому, скорее всего, ну, мне кажется, до конца этого месяца уже третий запуск ракеты Ньюфгрен не состоится. Там ни видеора не было, ни ничего, и не вывозили даже еще на площадку. Вот, также 7 апреля может состояться запуск ракеты Минотавр-4 с миссией STP-39А, а 9 апреля запуск ракеты Вега-Си с миссией Смайл. Ну и самое важное, конечно, самое интересное, то, что 1 апреля в 23:24 по EDC, возможно, наконец-то состоится запуск ракеты Артемис-2 с миссией в пилотируемый обрет Луны на ракете Space Launch System, который, боже, должен был состояться еще в феврале, а вообще еще бог знает сколько лет назад. Ракета СС еще с 19 марта находится на стартовой площадке. VDR в этот раз не планируется. И у нас остается минута до запуска, до второго запуска ракеты Isar Spectrum с миссией Onward and Upward. Смотрим.
Sequence is started. $45. T-minus 30. T-minus 10. Let's go, Spectrum.
Ну, конечно же, ход. А как иначе? А таймер идет себе в плюс. Отсчет времени, будто оно полетело. Ну, конечно же, ход. А как иначе? И тем временем до конца стартового окна у нас остается 29 минут. Конец стартового окна в 20:50 по EDC, так что, мне кажется, не полетит оно уже сегодня. Потому что, не знаю, 29 минут, мне кажется, мало. Причем это прям практически, что аборт был, но зажигание двигателя-то не началось, но даже уже началась система, ну вот это VDS или DSS, не знаю, что оно у них там. Да, ну, чё, пока ждем.
Folks, we are standing by here as soon as we get more information from Mission Control. It's important to me. I don't want to guess as to what goes on here. I mean, Nico is back with us. Nico, so many different sensors, so many different leads, so much different information. There's a lot of different things that could be happening right now.
Yeah. At this point, we don't have any precise information as to what exactly the reason for the abort was, but we know all the checks that the vehicle does at these final moments. So we need to ensure that all the systems that are critical for mission success are within their required envelope to proceed with flight. So that being tank pressures, that being CPV storage pressures or helium gas pressures.
Right.
Shortly before going into actual engine ignition, we want to make sure that the rest of the system is in a good health to also ensure that we don't have another cycle on the engines themselves. Now, we can only speculate what the exact reason was, but one thing is for sure, it's always a fine balance of making sure you don't have too many checks, but still enough to ensure that you can go on with the vehicle for a successful mission.
Right. As soon as we get more information as to the cause of that abort, we will be back and share it with you. But Nico, you're exactly right. We're not going to sit here and guess about all the different things. Remember, 100,000 different things have to go right in order for the launch to occur. One thing might have been out of bounds, and we'll get you more information on exactly what that was as soon as we can. We might not get it right now, even.
Yeah.
So, again, if you are just joining us and wondering what's going on, in the upper right-hand corner of your screen, you can see that we have a hold. We ran out of time there, and we got an abort right before liftoff. The range did clear. Like right there at the very end, I was able to come back, and I got confirmation that the range had cleared, but the abort kept us from lifting off here. We're going to let you continue to watch the vehicle, and as soon as we get more information, we will be back to share it. All right, folks, we continue to stand by for more information here, but I do want to stress we may not get the complete cause tonight, right, Nico?
Yeah, we need some time to look into it. I'm sure the engineering teams right now already have some understanding of what's happening, but we need to look a bit further to understand exactly what the cause was, and the root cause of that.
So we'll continue to stand by here and see if we do get more information, and as soon as I get more information, we will share it with you. Now, I will say, you should follow along on Isar's social media and their website. Over at isaraerospace.com, you can get official updates from there.
Yes. Exactly. And we're always looking for very brilliant people to help us there. So it's great to see people with interest to contribute to our mission. At the same time, it might not be the outcome we hope for today, but it's still an opportunity to learn a lot from it. And I want to thank also the teams for all the passion and the drive, especially since F1. I'm pretty sure that we're going to be ready to go again very, very soon.
Right. Makes sense. Again, folks, stand by. I'm getting just a little bit more information here. Okay. So the official information here at the beginning of the stream, we did say that we were working with a 15-minute window, and the delays with the range violation and then the abort at the end means that we are out of launch window for this evening, so that will be the end of the attempt for tonight. Again, please make sure you follow along on Isar's social media and the official website, isaraerospace.com. Of course, they'll work to determine what the issue was this evening and see what we have for upcoming launch dates and windows as well. Nico, as always, it's fantastic here being with you talking about rockets.
It was great being here. I'm looking forward to getting here as soon as possible again for our next flight to attend.
Absolutely. Folks, Nico Parakis, Chief Engineer for Spectrum, thank you so much for joining us.
Thank you, John.
All right. And again, folks, say thanks to Isar this evening, giving us all the fantastic views of the pad. The drone shots were fantastic.
Oh, yeah. They were
both
spectacular.
Inside and outside of the factory. I know that we all wanted to see a launch tonight, but you'd rather be on the ground wishing you were flying than flying wishing you were on the ground. And tonight, we've aborted the Flight 2 for Spectrum's launch attempt. I'm John Galloway with NSF. We appreciate you watching, and we will see you for the next attempt of Isar's Flight 2.